Once again, hello to all my friends. Today in this video lecture, I will discuss the limit test for heavy metals. So, the limit test for heavy metal is a official quantitative or semi-quantitative procedure which are used to detect or to control the extent of impurity, that is the heavy metal present in a chemical compound or present in a pure substance or present in a drug substance or a drug. So this particular limit test, that is the limit test for heavy metal, is designed in order to determine whether a chemical substance or a chemical compound, whether it contains heavy metal as an impurity or not. And as the name suggests, that is the limit test, it is used to know if the heavy metal is present as an impurity. In such a case, that particular impurity, that is the heavy metal, is present within a permissible limit. So this is what the main aim of this limit test for heavy metal. And as we all know that heavy metals are quite more toxic to human body, or heavy metal when taken internally even in a minute quantity, they can be well able to cause toxicity which is sometimes be fatal. So in order to, or it is hence necessary to first, it is necessary to know that whatever the drug compound or the drug substance is used as a medicine, or whatever the chemical which is used as a medicine, it must be free from heavy metals anyhow. And in a case where it is much more difficult to remove or to free a chemical compound from heavy metal, it is necessary to, in such a case, that whatever the heavy metal is present as an impurity in any chemical compound or in a drug substance, it must be present within a permissible limit. So generally, each and every heavy metal, if present as an impurity, it must be present within a permissible limit, and the unit to express the permissible limit of a heavy metal in any chemical compound or in a drug substance, it is ppm, that is the particle per million. So this particular unit, that is the particle per million, itself suggests us that if an heavy metal is present as an impurity, it must be present in a very, very, very minute quantity, so that it should not be cause any toxic effect with the body. So let us discuss the principle involved in the limit test of heavy metal. And as I discussed earlier in other limit test, this particular limit test, that is the limit test for heavy metal, is also based on a simple chemical reaction whose outcome is the production of color. and the color whatever is produced by the standard is then compared with the test in order to determine whether the test passes the limit test for heavy metal or whether the test gets fail. So accordingly, on the basis of extent of color produced by the test sample, which when compared with the standard which is having a permissible limit of heavy metal, that particular test can accordingly be passed, and it can also be get fails according to the intensity of color so produced by it. So let us discuss the principle on which the limit test of heavy metal is based. So the limit test of heavy metal is based on a very simple reaction between the metallic impurity whatsoever is present in a chemical compound or in a drug or in a drug substance. When this particular metallic impurity comes in contact with the hydrogen sulfide in presence of acid or in an acid medium, this will result in the formation of metal sulfide. This particular metal sulfide gets distributed in the colloidal state, and hence it able to produce a visual brownish or blackish color, and the extent of this brown or black color which is produced by the formation of metal sulfide is directly proportional to the net quantity of net quantity of metallic impurity which is present in the chemical compound or the drug substance. So accordingly, when a permissible amount of metallic impurity or when a permissible amount of a heavy metal present in a particular chemical compound or in a drug substance is able to produce a definite color, and that particular color is when compared with the test, we can anyhow we know whether the test or whether our sample whatever we are analyzing for the presence of impurity, we can anyhow quantify as well as analyze that the test can contain a impurity which is greater in amount or it have an impurity which is lesser in amount. So accordingly, this is the particular chemical reaction on which the limit test of heavy metal is based. So this particular procedure is applicable for determining the presence or permissible limit of metals such as lead, mercury, bismuth, arsenic, antimony, tin, cadmium, silver, copper and molybdenum. So all these metallic impurity if present in any chemical compound, they can be ultimately be ruled out by using this particular procedure, that is the reaction between or a particular reaction between the metallic impurity which I discussed anyhow, that particular metal ions if present or this particular metal if present in an chemical compound when reacts with an hydrogen sulfide under acidic medium, which it will be results in the formation of metal sulfide, and that this particular metal sulfide whatsoever is formed is able to produce a brown or the black color, which is ultimately be indicative for the net amount or indicative for the presence of particular quantity of heavy metal in a chemical compound. So let us discuss the chemical reaction involved. So I hear this is a representative reaction which I here discussed regarding the principle of limit test, and here this M indicates the heavy metal or the metal ion present as an impurity, and H2S is the hydrogen sulfide. So when this particular metal which is I represent here as a M reacts with an hydrogen sulfide under the acidic condition, this will result in the formation of metal sulfide which I represented here as a MS. then this particular metal sulfide which is formed here is able to produce a color, and the color that is the brownish color or the black color, which is ultimately be proportional to the extent of metal ion or the impurity, heavy metal impurity present in an particular chemical compound. So this is a representative reaction which itself is an explanatory, or which itself explains the limit test of heavy metal. So I again explain this particular reaction here, that when the metal ion, that is the M, when reacts with an hydrogen sulfide in presence of acidic medium, it results in the formation of metal sulfide, which is responsible for the particular color which I earlier as I discussed. And now further I will ultimately take the particular example of some of the metal ions, and ultimately let you people know how these particular heavy metals are ultimately be analyzed by this particular principle. So I further here describing more specifically the limit test of heavy metal by taking an example of lead. So I here take an example of lead nitrate, which is present as an impurity, that is a heavy metal impurity, and the metal which is present here is the lead. So according to the principle, when this particular lead nitrate, which itself contain the metal ion lead or the heavy metal lead, when reacts with the hydrogen sulfide, will under the acidic medium, that is in presence of acetic acid or in between the pH in between 3 to 4, this will result in the formation of metal sulfide, which I earlier also discussed in a particular chemical reaction. So this results in the formation of a metal sulfide. So when this lead nitrate reacts with the hydrogen sulfide, this will result in the formation of lead sulfide along with the byproduct, that is the HNO3. So this lead sulfide, which when it forms, it will appears as a brown or black in the color. And as I discussed, whatever the quantity or whatever the extent of lead present as an impurity in any sample, and according to this quantity, the lead sulfide will produce, and accordingly the color or the intensity of color will be. So for an example, if this lead sulfide, if the lead nitrate or the lead if present as an impurity in a lesser quantity, and when that particular chemical compound in which the lead present in a smaller quantity will reacts under the similar condition or under the same condition, and which results in the formation of lead sulfide. So accordingly, as the lead present in a smaller quantity, so the color whatever the so produced, that is the brown or the black color, it will be less intense in the color. And likewise, or in contrary, if that particular lead, that is the lead nitrate, is present as an impurity in any chemical compound in an higher quantity or in an high extent, to under that particular condition, the once a high quantity of lead if present in an impurity, it will ultimately reacts under the similar condition as we discussed in the principle. This results in the formation of greater amount of the lead sulfide, and hence more brown or the blackish color will be produced. So this is how ultimately we can correlate the color with the net quantity of metallic or heavy metal impurity present in the chemical compound, and anyhow we will ultimately be rule out our result or the outcome.